Hi everyone, this is 7th grade Elevate, lesson 57 on graphing proportional relationships. We are going to spend the first 4 minutes of this lesson on a teacher intro. Yesterday we learned about ratio tables, finding patterns of missing values within ratio tables. Now we're going to apply that learning to graphing proportional relationships. And so proportional quantities have a relationship where the quantities have the same relative size. We say they are within ratio of one another, right? And so relative size, we are talking about constants. So there is a constant distance between each of the values, right? And so when graph numbers with proportional relationships present as a line, you know by looking at a graph that it shows a proportional relationship when it fulfills two criteria. The first criteria is that the graph must always pass 0, 0. So the line meets at the origin, which is 0, 0. Step one, great. The second criteria for whether a graph is proportional is if it forms a straight line. So this line is straight, which means that this is a proportional relationship. So if you have a line that goes something like this, or working with coordinate grids, if you have one of these, this is not a proportional relationship. It must pass through the origin and be a straight line. Even if it's a coordinate grid, it would look something like this, or sorry, that didn't pass directly through the origin, but something like that. So looking at our ratio tables from yesterday, these are very similar to yesterday. The only thing is that this ratio table is now vertical instead of horizontal. Our X and our Y values still remain the same, okay? So in this example, we are talking about the time in hours and the total cost in dollars. So it says here, notice the point represented by a star on the coordinate grid. This is a special point that represents the unit rate. It is located at 150. Again, we have that value of 1 as our x coordinate, and so we know that this is our unit rate. The unit rate is defined by how much of something you have per 1 unit of something else. So the unit rate in the context of this problem is interpreted as the total cost of a luxury car rental is $50 per hour, right? So in 1 hour, I will spend $50 to rent out a luxury car. If I need to rent it out for 3 hours, I'm going to spend $150. And then if I need to rent it out for 8 hours, I am going to spend $400. There's no flat rate. I mean, this is a flat rate. There is no interest. There's no tax. $50 per hour. And so the other points on the line match up with the coordinates in this ratio table. So you are going to spend 3 minutes modeling this first example, the cost of gas. They have given you a graph. Looking at it already, we see it's a straight line. We see that it also passes through the origin. I can tell this is a proportional relationship. That is a question that you can ask the students. Does this graph show a proportional relationship? Yes or no? The kids should say yes. Okay. Then we go into this question, how many gallons of gas cost $60, right? So they're asking us, or they're giving us information about the cost being $60. So we want to make sure that we're looking at the cost and $60 specifically to find the answer to that question. So I'm looking for how many gallons of gas will cost $60, and I end up at this point right here, which tells me that 20 gallons of gas will cost $60. Then they ask, what does the point 1030 mean in the context of the situation, right? So 1030 is this point right here. They're asking, what does it mean? Well, it means that 10 gallons will cost $30. 10 gallons equals $30. So then we're jumping into some partner practice for 3 minutes 6 minutes. There's 2 questions, question 2 and question 3, before students jump into their exit ticket, which is question 4. And it is 3 questions: identifying the unit rate. Because you know that they're going to ask about the unit rate for this exit ticket, you may even want to ask students this question during your model: what is the unit rate? And it might be hard for them to see, but you might ask them, well, we know in a unit rate, our x coordinate has to be what? It has to be 1. So what do you think the cost would be? Where would 1 be on our x? 1 would be around here. And what do you think the cost would be if it's 1? So students might have to estimate, take a guess. They should know that it's less than 30, right? They'll give you some sort of estimate that's right here. Let's see what they come up with. Just to set them up for success for their exit ticket, they'll have to find the price of 5 cookies and then tell us what 1,50 means in the context of the situation. So 1 cookie costs 50 cents is what they should say.